Welcome back to the Science of Sailing program at Piers Park Sailing Center. This video is for Level 1 students studying marine science. Today we'll be learning about the tide cycle and the wind. Have you ever been to the beach and made awesome sand castles, but then a few hours later the water washed away all your hard work? If your answer is yes, I'm sorry. You can blame it on the tides. The tide cycle involves the ebbing and flooding of water on Earth. It's mainly controlled by something in outer space that's 238,900 miles away from the Earth, the Moon. To understand this, you can imagine a layer of ocean surrounding the Earth. The Moon exerts a gravitational force that pulls Earth's water towards it, because water is a flowing liquid that can move around. This creates a bulge towards the Moon, which we know as high tide. But on Earth, there are 2 high tides per day. So where's the other one? Surprisingly, the gravitational force from the Moon is so strong that it pulls the whole Earth towards it a little bit. The Earth has moved, but the layer of water opposite the side of the Moon doesn't move very much, creating another bulge that we see as the second high tide of the day. That's because it's farthest away from the Moon, so the Moon doesn't influence the side of the Earth as much. So essentially, the water closest and farthest away from the Moon gets stretched so that the other areas on Earth are in low tide. But don't forget that the Earth is spinning. This rotation is why there are also 2 low tides each day. High tides are spaced 12 hours and 25 minutes apart, and the same is true for low tides. This also means that one high tide is about 6 hours and 12.5 minutes apart from the next low tide, and low tide is also about 6 hours and 12.5 minutes apart from the next high tide. Knowing this, you'll always be able to tell when the next high or low tide is coming, so let's have some practice. Let's say that high tide is at 6 a.m. When's the next high tide? You know that high tides are 12 hours and 25 minutes apart from each other. So all you have to do is add 12 hours and 25 minutes to 6 a.m. That brings us to 6:25 p.m. for the next high tide. Try this one on your own. We have low tide at 12 p.m. When's the next low tide? Adding 12 hours and 25 minutes, we get 12:25 a.m. Okay, here's a trickier one. Let's say that low tide is at 11 a.m. When's the next high tide? This one's a little different because we're going from low tide to high tide. Pause the video and think this one over. Assuming you've tried this on your own, remember that high and low tides are 6 hours and 12.5 minutes apart from each other. So high tide will be at 5:12 p.m. Now let's move on to terms ebbing and flooding. The idea is that going from low tide to high tide means that the water level is rising, and we call this flooding. Ebbing is just the opposite. It happens when we go from high tide to low tide so that the water is receding from us. You can see this happen at Piers Park if you stayed long enough. Here the difference between high and low tide is about 12 feet. This difference in height between high and low tide is called the tidal range. You can see the tidal range just by looking at the barnacles that grow by the dock. This is the marking point for high tide, since the barnacles must live in an environment that's submerged by water at some point. You can also look at stationary locations, like the pier, to see how high the water line has risen or sunk. Some places have a tidal range of 43 feet, like the Bay of Fundy in New Brunswick, Canada. And this brings me to why we care about the tides and write them on the weatherboard at Piers Park. When we went on island trips in the pre-COVIDian era, we had to anchor our boats. Imagine the disaster that would happen if we dropped our anchors during low tide, and then high tide came and ripped the boats from the anchors and they drifted away from the island. Now that's a long swim home. Tides also create currents in the water that pull our boats in certain directions. It would be pretty hard to sail somewhere when the current is pushing against our boat. So we try to sail with the current that's pushing us. The wind strength and direction can also affect the currents and where we sail. Wind blows against the surface of the water and can make the tide stronger. You can't see wind, but you can definitely see the effects of it. The stronger the wind, the more ripples and whitecaps you'll see in the water, versus a smooth, glassy texture on a day without wind. The direction of the wind affects where we can sail, as you'll see in upcoming videos, so we always want to know where it's coming from. Here are 4 effective methods for determining wind direction. The first thing you can do is look at the telltales on your boat. They're tied to the shrouds of the sonars, so it's easy to see where the wind is coming from. The second thing you can do is also read the weather forecast to see which direction the wind's coming from. You can also look at something blowing on land, like a flag. Lastly, you can look at the direction that moored boats are facing because they always face into the wind. And now, it's time for a sad story. Please don't cry. Climate change is affecting or will affect every part of our lives soon, especially the tides at Piers Park. I don't know if you knew this, but the sea level is rising because polar ice caps are melting. They're flooding all of the oceans, and at this rate, Boston's sea level is changing 1 inch every 8 years. That doesn't seem like much, but there is a huge impact. People's homes along the coast are flooding, and Piers Park has even flooded once already because the tides got too high. Not to mention that all our charts from 2001 will have inaccurately labeled water depths. Yikes, let's hope we don't crash into anything. And that concludes our sad, sad story of the tide cycle and rising sea level. Goodbye.